Okay, so you're gonna prove that this is surjective. So let y be any arbitrary element, let y be any arbitrary element in the codomain. Okay, so what do you have supposed here? Let y be any arbitrary element in the codomain. Okay, so y is any arbitrary element in the codomain, and if there is an x for that y, what does that mean? It means that is surjective. So this is what we are going to do. So this f of x, now here we're going to write y. Okay, so y will be equal to 3x plus 4. Okay, why? Because y is the output, y is the image. Okay, any arbitrary element in the codomain. Okay, and for that arbitrary element in the codomain, we're going to find the x. So this is going to be y minus 4 is equal to 3x, and x is going to be y minus 4 over 3. Okay, it means there is an x for any arbitrary y, okay, in the codomain. It means it is surjective. Okay, so what do you have come up with here? For all y in codomain, for all y in codomain, there exists what? X is equal to y minus 4 over 3 in the domain, such that f of x is equal to y. Does it make sense? So so it is surjective. So it is the function is what? Surjective. It is surjective. Okay, so this proves surjection here. Okay, so for all y in codomain, there exists an x in the domain such that f of x is equal to y. So it is surjective. Okay, so this is what it means. So it means that the function is surjective. Now the second problem is just the same. There is no any too much difference, but yeah, here what you have to prove is that this is surjective but not injective. Okay, this is what we have to prove in the second example. Okay, so yeah, you can do the problem on your own too, but here right now I'm going to do this. Okay, so this is not that difficult. This problem is also easy. Okay, so now you can go and try on your own this problem, but I'm recording this. Okay, but you can go and try this problem on your own. Okay, so the second problem, we have f r to r, okay, and f of x is equal to x squared plus 4, and we have to prove that this is surjective but not injective. Okay, so how are you gonna prove in the first place that this is injective? Okay, so we're gonna let x1 and x2, okay, be two elements, okay, be two elements such that f of x1 is equal to f of x2. Okay, and this we're gonna let. So f of x1 is equal to f of x2. So this is going to be x1 squared plus 4 is equal to x2 squared plus 4. Okay, and then the 4 will cancel out, and we're gonna have x1 squared is equal to x2 squared. And now if we solve for x1, so x1 will be equal to what? Plus minus square root of x2 squared, which implies that x1 is plus minus, okay, x2. So it means what? It means that if you pick up an x1 equal to x2, Okay, if you pick up an x1 which is equal to x2, and if you pick up another x1 which is equal to minus x2, then they both give you the same answer. Okay, meaning the output will be equal. Okay, so it means that x1 which is equal to x2 and another x1 which is equal to minus x2, they both are squared. Okay, or this is not only squared. Okay, you have 4 to add 2. Okay, so if we plug those into this function, both of them will give you what? The same answer. F of x1 and f of x2 will be the same. Hey, tell them not to make a noise. Okay, it means what? x2 and minus x2 both are mapped to what? The same thing, f of x1. Okay, x2 and minus x2, or f of x2, you can also say both are mapped to, so x2 and minus x2 both are mapped to f of x2. Okay, because f of x1 and f of x2, they both are the same thing, so you can write f of x2. Okay, so x2 and minus x2 both are mapped to f of x2, which means what? This implies that this is not injective. Okay, so no, not injective. Okay, the function is what? Not injective, because it is not a one-to-one. Two inputs here, x2 and minus x2, they both map to same thing, f of x2 here. Okay, that's the reason. This is why it is not injective, but it is surjective. Why it is surjective? Let's show you that. Why it is surjective. To prove that it is surjective, we're going to use the same method that we used for the first question. Okay, so we're going to let y be any arbitrary element in codomain. Okay, in codomain. Okay, so you're going to let y be any arbitrary element in the codomain. So this means y is equal to x squared plus 4, and x squared is going to be y minus 4, and x is going to be plus or minus square root of y minus 4. So this is what your x is. It means what? For each y there exists, okay, actually there is existing 2 answers here. Okay, but it's fine if whether you get 1 answer or you get 2 answers, it's fine for surjection. It means there is an element in the domain D, okay, or the set D, such that f of that element, let's call it x, f of x is equal to y. Okay, so this is your C. Okay, it means but in fact here for this case actually there are 2 elements. Okay, you can see here plus or minus. Okay, so you might have x1, let's say, and minus x1. Okay, both mapping to one exact same element. Okay, so, but there does exist in the element, in the domain, such that f of x1 or maybe any element f of x is equal to y. It means what? It is surjective. Okay, so it is surjective. Okay, so this function is surjective. So this was it for this video, and see you in the next video.